Hey guys! So today you and I are going to talk about optimization. Let's get into it. So the question in question was, hi Frederick, when you're thinking about optimization, what about choosing the right language for it? Okay, so let's first and foremost talk a little bit about my thoughts about optimization and sort of what I consider when I do optimization, because usually I sort of categorize them into two different things, and I'll tell you why that is and why I think that that categorization is the most important thing that you can do when you're talking about improving performance or optimization. So what I mean by saying that there's two categories is that I argue that there is optimizations or performance improvements that can be done in the code itself, the hardware, sort of what you're indicating here, because you're talking about a specific language, right? So what we're usually considering in those situations is like memory consumption, CPU usage, like things like that. And if we are talking about the other type, which is less discussed in the nerdier parts, let's just call it that, of the interwebs, where all the C++ and C developers and Rust and the Golang and so forth and all the cool developers who talk about these things, like usually where they hang out, is delivery speed, delivery performance. That is the thing that every single company discusses, usually, at the very least. Like the concern of the product developers around the world and product owners and company and business managers and so forth is more a question of, all right, so how do we ship code as quickly as possible? How can we increase the amount of pull requests that are going through, or amount of story cards we're delivering, or things like that, right? Now the reason why I want to make that distinction is because one of the most, I argue, foolish things that software developers do is that they make the code about themselves. And what I mean by that is basically that you start thinking in terms of what you want to do with the software that you are writing, and you are forgetting why you are writing the code in the first place. Your goal with the code is not to satisfy your own need for optimization, for example, which is like there's a whole branch of people who absolutely love to tweak every little detail and increase own notation, perfect their own notation and stuff like that. These are all good things, but you can never forget the reason why you're doing it. And the reason why you're doing it is usually so that the code you are writing on behalf of somebody else works and meets the criteria and all that sort of stuff, right? And so what can very easily happen for software developers is that they do the thing that, like the way I describe it is, if you are selling your skills as a craftsman, let's say that you are a carpenter or something similar to that, and you have a customer who asks you to build them a really nice shed. If you are mature and business-minded craftsman in that situation, you will build a shed, a really nice shed that makes them really, really happy. They're going to recommend you to all their friends, like this guy or girl, like they can build a really nice shed, right? The thing you don't want is to start thinking in terms of, okay, they want a shed, but I want to build a skyscraper. And all of a sudden you start building something that has more with you trying to indulge your own need for engineering challenges and things like that, right? And so that is the thing and the distinction I want to make here, because usually it's better for you to think in terms of optimizing delivery speed, because it's a really, really rare, at least in my part of the woods where it's like all web development. I would go as far as to say that I think I can count on my 5 fingers how many times the language choice has been the most determining factor as to how well the system works. So a good ratio to keep with you is 80-20, or maybe, I mean, in this case it might even be 90-10, right? Most of the time what you're looking for is to increase development speed, not runtime efficiency per se. There are situations where that is not true, I'll tell you when. Anywho, so start by considering that, and when I pick a language, for the first and foremost case, make sure that everybody can deliver as quickly as possible, then I usually pick something that is very, very like mainstream. I know that I can hire a lot of people that know it. I know that juniors can adopt it. There's tons of learning resources, tons of standard libraries for everything that they want to be able to do, and so forth and so forth. And then I put the rest of it, because like the language choice in that situation is really just honestly go and look at the top used, not popular, used, industry used languages, and you're going to find it's the same, like the usual suspects. It's going to be JavaScript, C# and Java. That's like the highest level. It depends on your region, of course, as well. You have to like that's usually a global number based on what I have seen at the very least, but it's the same deal. So you go and pick something that is super stable and well known. Same thing with front-end development. You pick the stuff that most people are using these days, and that way you know at the very least that you're going to be safe in terms of delivery speed. The rest of it is, of course, like there's other videos. You can do tons of stuff in this area, but that's what I do when I do tooling type of things. Even if I might want to use something else, I try to make sure that I'm not thinking about myself here. I'm thinking what's going to be good for the team, what's going to be good for the project, and how am I going to make sure that if I'm not there, or like a classic one is some senior developer somewhere picks like a really niched language or setup or stack or something like that, and basically the whole system fails, or the whole project and the product itself has issues due to the fact that they are the only ones who can deal with this situation, right? However, when I do need performance, then the most important thing for me is to consider, all right, to what degree do I need that performance? Again, because it's a balancing act, because I can always go and say that everything that is performance related, just make it in C, for example, or make it in Rust. I can always make that argument. It's the same thing with Golang and so forth. But again, I'm breaking rule number one. Rule number one is to make sure that I get the performance that I like, that I create the simple setup, so that the delivery speed is not impacted while meeting the criteria. Because that's the thing about performance. You can always make something more performant, but as I said in earlier of my little rant here, the thing I'm after is to make my customer happy. And again, with my shed analogy, let's move that to cars, because now we're talking performance. So my customer wants me to build them a car. And my first question to them would be, what type of driving are you going to do? Are you going to use it to like just have some small kids ride around in like a little track, like a go-kart or something like that? Are you going to use it like as a personal vehicle or something like that? Or are you going to be racing in Formula 1? That is a very important question to ask yourself when you're thinking about performance. You have to know where is the criteria for success, because you can always go on the forums and debate with people over how do you get bleeding edge performance, and usually the only time that really matters is in competitions. Practically every company who's using Rust, Golang, or so forth, what they are usually doing, they're not necessarily going and checking what right now is the most performant thing. They're usually looking at these languages because they have a specific system or a specific service. Like classic one is like high computation stuff. Let's say that you have something similar to something that's going to crunch a lot of numbers. So I actually have a system that I work with, which basically it traverses and processes I think it's about a terabyte of JSON data. That's per job. That's insane amounts of data that needs to be read into memory and managed and stuff like that. In a situation like that, I know that I need memory control and I need to have a really efficient CPU usage. And so in such a situation, I might look at Golang. Depending on my personal favorite would be Rust, for example. That would be my choice because of these benefits and so forth. But I mean, I could have looked at C++ and so forth as well. But those would be the choices that I would have made, because those languages are extremely well made for such a scenario. But I would never do that for a regular, REST API, which doesn't require that sort of optimization. And that's the way I want you to think about optimization. Most of the time, optimization is it's your average language, like every single language, guys. Like it doesn't matter if people call it slow or not, will be able to do a lot of stuff. So really think about the delivery optimization first, because 80% of the time that's what's going to be the best choice for you. And when you have a situation where you know that as a classic one, is if you have to sit and wait for too long, now you know that you need to start thinking about the language and the tooling and the algorithm, like the annotations and stuff like that. Because when things are being slow in terms of execution, that's when this sort of optimization becomes relevant. So what I want you to take away from this is that the way that I think about optimizations is that there are two: delivery speed and runtimes, or like execution of programs and stuff like that. People who talk about optimization are in our neck of the woods usually more about runtime efficiencies and annotations and things like that, which is great for us engineers to consider because it is an important factor, especially, as I said, if you have a situation where you need that, then you really need to think about this sort of stuff, and that's how I explained it to you. Usually I don't write a whole system in, say, Rust, and neither did Uber, for example, when the Golang became a thing. Like, people thought that I still remember the article. They very clearly stated that they had a few services that they wrote in Golang because those did exactly the thing I was talking about. They were, I think, if I remember correctly, don't quote me on this, they were calculating geometric spaces on maps, and that's just number crunching. Perfect situation to use something like Golang, or like to sort of off, because that service was being hit by like all the other services in their ecosystem. So it has a lot of traffic, it has to run really, really quickly. Perfect situation to say, you know what, we're going to opt in to a more sophisticated solution because we really need it. That's what you should be doing. Should be doing exactly the same thing. And my personal preference is Rust. That's my personal favorite for like this sort of stuff. But if my team were all gonna go and like say, I can never figure out that borrow checker, I would say, okay, let's just do a benchmark with Golang, for example, and see if we can make that work, or so forth. I would make a pragmatic choice there. But most of the time, the thing you're looking for is easy to understand code, like the language should be mainstream, easy to hire for, so that if people needs to be switched out or so forth, or you need to hire people very quickly, you can, and tons and tons and tons of like documentation and stability in the ecosystem and stuff like that. That's not stuff that you necessarily will get from Rust and Golang, even though those languages are pretty cool if you ask me. But that is the difference between perspective, and I hope that you keep with you both of these, because as I said, most of your business co-workers and your companies and your bosses and so forth will care more about their ability to ship code quickly, and most of the time the things that they want you to build do not require bleeding edge like runtime performance. So consider that. And then when you find a situation, as I said, maybe a lot of data crunching or something where you have a concrete situation where you can prove that actually we need this to run a lot quicker, then you start considering, okay, what language should I pick? Is there a way for me to increase machine scale? Like, can I do parallel stuff? Can I make a more effective algorithm? Stuff like that. Have a great day.